So I welcome you once again to my channel. My name is Ayodeji Felix Isariade. Um, in our last class, we discussed differential equations, where we talked about dependent variables, talked about independent variables. We also talked about classification of differential equations. We talked about classification by types. We talked about classification by order and classification by linearity. So if you haven't seen the video, kindly go back to check it out. And don't also forget to click on the subscribe button and turn on the notification bell for more updates. So today we'll be looking at solution of first order ordinary differential equations. And we are going to be solving these ordinary differential equations that we are seeing. So, but let's first talk about the solution of first order ordinary differential equation. What do we mean by solution of first order ordinary differential equation? So let's consider this equation. Let's say y equals 3x raised to power 3 plus 4x squared plus 5x plus 2. Now, if you differentiate this, we are going to have the y, the x equals 9x squared plus 8x plus 5. So by implication, equation 1, let's call this equation 1 and let's call this equation 2. Take note that equation 1 is not a differential equation. Equation 1 is not a differential equation. Equation 2 is called a differential equation because it contains differential coefficients or derivatives, as it were. So in that case, equation 2 can be referred to as a differential equation. Then what then is the solution of a differential equation? Now, if you integrate equation 2, let's integrate equation 2, the y, the x equals 9x squared, the x plus integral 8x the x plus 5 the x. So if you integrate this, let's see what we are going to have. If you integrate the y, the x, you are going to have y. This will give you, if you integrate this, you are going to have 3x raised to the power 3, and you're also going to have 4x squared, and you're going to have 5x plus c plus the constant. So you can see clearly that our answer here is equivalent to equation 1. This c is a constant which represents this 2, because 2 is also a constant there. So by implication, therefore, equation 1 is the solution of the differential equation 2. Differential equation 2. So equation 1 is not a differential equation, but a solution to the differential equation, which is being recognized here as the equation 2. So you have to take notes. So the equation that does not have a differential coefficient but satisfy the differential equation is called the solution to the differential equation. So the solution, an equation that does not contain differential coefficient but satisfy the differential equation is called the solution to the differential equation. So therefore, since equation 1 satisfies equation 2, then equation 1 is called the solution of a differential equation 2. So now we are going to be considering some methods for solving first order ordinary differential equations. We have so many methods, and I'm going to list them for you. Methods for solving first order ODE, ordinary differential equations. Number 1 is called separation of variables. Separation of variables, or variable separation. Number 2, homogeneous equations by substituting y is equals to vx. Number 3 is exact differential equations. Number 4, integrating factor method. Integrating factor. Don't forget that we are dealing with, so integrating, for you to use integrating factor, it must be linear. It must be a linear ordinary differential equation before you can make use of integrating factor. Number 5, we have what we call Bernoulli equations. So for this class, we are going to be considering the first method, which is separation of variables. And we shall be using this method to solve the following problems. Follow me closely. The first method, let's call it A, separation of variables. Separation of variables. Now, when an equation when I say an equation, I'm talking about ordinary differential equation. So when an equation is of the form is of the form the y, the x equals f of x, g of y. Then we can say that the variables are separable, or the variables can be separated. So therefore, we can say we have f of x comma y equals f of x, g of y. So it means f is a function of x and f is also a function of y. So by this understanding, we're going to be using this method now to solve the following problem. So the first question here says solve example now. 1. Solve the y, the x equals y plus 1 over upon x plus 1. So when you have this solution, given the y, the x equals y plus 1 over x plus 1. So the first thing you have to do here is to cross multiply. So when you cross multiply, you are going to have the y into x plus 1 equals this, we multiply this, y plus 1 into the x. What we are trying to do is that variable y's, or the terms containing variable y's, will be separated on one side, and variable x will also be separated on another side. So here, our interest now is to have the y with y plus 1 and to have the x with x plus 1. So we can say that divide both sides by x plus 1, y plus 1. So when you do that, you are going to have x plus 1, the y, over x plus 1, y plus 1 equals y plus 1, the x, over x plus 1, y plus 1. So this goes with this goes with this. So we are left with the y over y plus 1 equals the x over x plus 1. You can now see that the variables have been separated successfully. This is y, this is the y, this is x, and this is the x. So by implication, the next thing to do here is to integrate both sides. Integrate both sides. So when you integrate both sides, we are going to have integral 1y plus 1, the y, equals 1 over x plus 1, the x. Now, this is an integration question with fraction. So when you want to integrate a fraction, what you have to do first is to examine the denominator. When you look at this denominator, you will see that if you differentiate the denominator, you are going to have the numerator. Therefore, anytime you differentiate the denominator of an integral related question and your answer is equivalent to the numerator, you are going to say that this will be ln denominator plus c, or log denominator plus c. So this is logarithmic function. So whether you call it ln or you call it log, natural logarithm. So by implication, based on this knowledge, if you integrate this, you are going to have ln y plus 1 equals ln x plus 1 plus c, where c is called constant of integration. Now we have ln here, we have ln here. To eliminate it, we are going to introduce exponential function. So you will just say that take exponential, of both sides. So it means you're going to have exponential ln y plus 1 equals exponential ln x plus 1 plus the c, the constant of integration. So take note that anytime exponent and exponential function is being raised to a logarithmic function, they will cancel each other. So this, we cancel this, then we are going to have y plus 1 equals x plus 1 dot exponential c, which is the exponential function of the constant of integration. So this is equivalent to y plus 1 is equals to x plus 1 dot c, where c is equals to exponential c. So this is the solution to the question, to question 1. So question 2 says x squared plus 1 over y plus 1 equals xy, the y, the x. So when you do this, we are going to follow the same procedure, and we can rewrite this as, you can still rewrite it as xy, the y, the x equals x squared plus 1, y plus 1. I only rearrange it so as for us to have the y, the x on our left-hand side. So when you do cross multiplication, you are going to have xy into y plus 1 dy equals x squared plus 1 x squared plus 1 the x. You will see that what we want to do is to separate the variables. We don't want this x here. We want this x to come to this side. What we are going to do there is that we are going to divide both sides by x. Divide both sides by x. So when you do that, you have xy, y plus 1, the y, over x equals x squared plus 1 over x, the x. So this cancel this. You have y plus 1, the y, equals x squared plus 1 over x, the x. So the next thing to do is to integrate both sides. Integrate both sides. So here we are going to, if you open this bracket, you have y times y. Integrate. So y times y, we have y squared, y times 1, we have y. The y. And this is the same thing as equal to, this is the same thing as, recall that this can be expressed as, this x is serving as the LCM of x squared and 1. So we can write this as x squared over x plus 1 over x, the x. So that is the implication. This is the same thing as this, because if you take the LCM, you are still going to arrive at this. So this will give you, if you integrate this, you have y cubed over 3 plus y squared over 2. You have x here, you have just a single x. So when you integrate that, you're going to have x squared over 2. And when you integrate 1 over x, you are going to have ln x. I've told you the other time that if you want to integrate a fraction, you have to look at the denominator. So if you differentiate the denominator and your answer is equivalent to your numerator, you are going to make use of a logarithmic function or natural logarithm. So if you integrate this, you are going to have ln x plus c, where c is a constant of integration. So this is the solution to question 2. Question 3 says the y, the x equals 1 plus x, 1 plus y. Given the y, the x equals 1 plus x, 1 plus y. Don't forget that our interest is to do what? Is to separate the variables. So when you cross multiply, you have the y equals 1 plus x, 1 plus y, the x. Our interest is to bring this 1 plus y to this side so that we'll be left with 1 plus x, the x on the right-hand side. So what you are going to do here is to divide both sides. Divide both sides by, there is the x here. Divide both sides, divide both sides by 1 plus y. So when you divide both sides by 1 plus y, you are going to have the y upon 1 plus y equals 1 plus x, the x. So the next thing to do is to integrate both sides. Integrate both sides So when you integrate both sides, you're going to have 1 over 1 plus y, the y, equals 1 plus x, the x. So this will give you ln 1 plus y equals, if you integrate this, you are going to have x. If you integrate a constant, you are going to have this. If you integrate 1, you are going to have x plus x squared over 2 plus c, where c is a constant of integration. So this is our final answer for that. So the last question says, solve 1 plus x cubed, question 4. Solve 1 plus x cubed, 1 plus x cubed, the y, the x equals x squared, given that x is equals to 1 when y is equals to 2. This is a bit technical, so pay attention. Solution. So we have been given this. So the first thing to do is to separate the variables. So we have 1 plus x cubed, the y, the x equals x squared y. So the first thing to do here is to also cross multiply for better understanding. So when you cross multiply, you're going to have 1 plus x cubed, the y, this will go to this side. You have x squared y, the x. So our interest is to bring this y to this side and take this to this side. So we are going to say that divide both sides, divide both sides by 1 plus x cubed and y, because we want to take y to this side, then we want to take this to this side. So when you do that, you're going to have 1 plus x cubed over 1 plus s cubed y, the y, equals x squared y, the x, over 1 plus x cubed y. So this goes with this, and this go with this. So what do we have left? We have 1 over y, the y, equals x squared over 1 plus x cubed, the x. So the next thing to do here is to integrate both sides. Integrate both sides. So when you integrate both sides, you are going to have 1 over y, the y, equals integral x squared over 1 plus s cubed, the x. Now, you have to be very careful. I told you earlier that whenever you want to integrate a fraction, the first thing to do is to look at the denominator. Now, when you look at this denominator, if you differentiate the denominator, you will notice that you are not going to get your numerator. So the answer will not be the same. So in this case, you are going to apply a different method entirely to integrate this. So when you look at it critically, the first thing you are going to do is to introduce a special variable that is not part of the two variables that have been given. So you can call that variable any alphabet of your choice. So we can call it u. So we want to deal with this right-hand side first because of this denominator. So we are going to have, don't forget that if you integrate this, if you integrate your left-hand side, you are going to have if you integrate this, we have ln y. Because if you differentiate this denominator, your answer will be 1. That is why we have ln y equals integral x squared over 1 plus x cubed the x. So you will say that let u be equals to 1 plus x cubed, this denominator. Then differentiate this. When you differentiate the u, the x, we are going to have 3x squared. Then, therefore, the x will give you the u over 3x squared. So if that is the case, then you are going to substitute u and the x into this equation. So you are going to have ln y equals integral x squared over, this is your 1 plus x cubed is given as u. We have used u to represent that, dot the x. The x now is now du over 3x squared. Thus du over 3x squared. So you can see clearly that this is s squared, this is s squared. It will cancel each other. Then we are left with what? Ln y equals integral 1 over 3u, 3 times u, the u. Now, this 3 is a constant, so we can bring it back. So we can rewrite this as ln y equals 1 over 3 integral 1 over u, the u. So when you do that, you are going to, if you now integrate 1 over u, you have ln u. Because if you differentiate u, you are going to have 1. So by implication, we have ln y equals 1 over 3 ln u plus c, the constant of integration. Don't forget that anytime you are integrating, you must not forget the constant of integration. So it can be any alphabet of your choice, but you can make use of u, you can make use of k, you can make use of c, you can make use of any alphabet of your choice. So from here, we are going to bring back 1 plus s cubed because u is not part of the problem we are trying to solve. We only introduce u so as for us to get rid of this denominator. So by implication, this can be written as but u is equals to what? 1 plus x cubed. So by introducing u, we have ln y equals 1 over 3 ln 1 plus x cubed plus c. So by implication, we can now say that multiply through by this 3. Multiply both sides by 3. If we do that, 3 times this, we have 3 ln u 3 ln y equals 3, we cancel 3 here, we'll be left with ln 1 plus x cubed plus 3c. Don't forget that we are multiplying through by 3. 3 times c, we have 3c. So from here, from the law of logarithm, recall that if you have 2 log 10 base 10, this is the same thing as 2 anyways, which is still the same thing as, you can still write this as log 10 raised to power 2 base 10, which is the same thing as what we are having here. This is a logarithmic function, so we can take this 3 to be here. So we have ln y raised to power 3 equals ln 1 plus x cubed plus 3c. So by taking exponent of both sides, taking exponential of both sides, we are going to have exponential ln y cubed equals exponential ln 1 plus x raised to power 3 plus 3c. I've told you earlier that when an exponential function is being raised to a logarithmic function, they will cancel each other. So this will cancel this. And this will also cancel this. So we'll be left with y cubed equals, this is the same thing as 3c equals 1 plus x cubed dot exponential 3c. So which can actually be seen as, which can be represented as any alphabet, which is the same thing as 1 plus x cubed dot c, because this is a constant. So this is a constant, so that's why we are having this. But recall that we have been given that x is equals to 1 when y is equals to 2. So what this means is that our final answer will not have any constant. We want to eliminate this constant c, and that was the key reason behind these two initial conditions. So our x is 1 when y is equals to, so anywhere you see y, replace it with 2, and anywhere you see x, replace it with 1. So here we are going to have when x is equals to 1, y is equals to 2. So this will be 2 raised to power 3 equals 1 plus 1 raised to power 3 dot c. So we are going to have c now. This will be 8 equals 1 raised to power 3 is 1. 1 plus 1 is 2. That means 2c. 2c. So c equals 8 over 2, which is equals to 4. This is not your final answer. Then you are going to bring back the value of c back to this equation. Back to this equation star. Because this is supposed to be our final answer if we were not given the two initial conditions. But because we've been given the initial conditions, we have to replace the value of C, which is 4. We have to replace it here. So we are going to have substituting 4 for C in equation star. If you substitute that in equation star, you are going to have y cubed equals 1 plus x raised to power 3 dot 4. And this is our final answer. So in our next class, we'll be looking at the second method for solving ordinary differential equation, which is homogeneous equation by substituting y is equals to vx. If you haven't subscribed, kindly click on the subscribe button and turn on the notification so as for you to receive updates of the next video. So thank you for joining my channel. Stay blessed.